Scientists, with the help of a detector IceCube, have been able to detect a completely exceptional view of our Milky Way galaxy, using particles that emanate from the reactions that power stars. The detector was buried in Antarctic ice, which used ghostly particles rather than photons. Professor Subir Sarkar from the University of Oxford told BBC News, "This is the first time we're seeing our galaxy using particles rather than photons of light." He further explained that this provides a view of high-energy processes that shape our galaxy. They are formed as cosmic rays smash into other matter, and detection of these collisions, neutrinos, is not easy. The neutrino is a ghostly particle. It's basically almost without mass, said Professor Sarkar, adding that they're essentially moving at the speed of light and might pass through the galaxy and not interact with anything. That is why, in order to see them, you need a massive detector. The detector was placed with thousands of sensors on long cables, drilled and frozen into a 1 kilometer cubic block of ice. It was buried close to the South Pole. Essentially, by knowing which sensor is triggered and at what time, we can reconstruct the direction that neutrino came from. The discovery, published in the journal Science, is an entirely new window into our galaxy, according to scientists. The Milky Way Galaxy was first discovered by astronomer Edwin Hubble around a century ago, revealing that ours was just one of millions of galaxies. Professor Naoko Kurahashi-Nielsen, a physicist and member of the IceCube team, said, "Humans had been studying it for millennia. We've seen it in many wavelengths of light, like radio waves and gamma rays, but since the dawn of time, it was always in electromagnetic radiation. In all wavelengths of light or photons. This is the first map of our galaxy in something other than light, and it's in high-energy neutrinos," she told BBC News, while mentioning that it will mean we can start understanding the physical processes in the Milky Way better. Professor Kurahashi-Nielsen added that the team would spend the next 5 to 10 years trying to answer questions that we can finally ask.